Here's what the Python Connect 4 game is going to look like. We're going to run our file here. It's going to display our board, and it's going to ask us for some input based on columns 1 through 7. I'm going to drop it 6. Now, if I try to drop it in column 9, it's going to ask me again. O's turn again. Please pick a number 1 through 7. Column 1. Keep dropping them wherever I want to. Just like this. 3, 5. X is the winner. Program's done. And that's Connect 4. What's up, YouTube? Today we're going to be coding Connect 4 in Python. This is going to be a command line game that takes some user input in and processes it with the game board until there's a winner. So to get started, we're going to define some constants for the board size of our Connect 4 game. Perfect. Now, we're going to use those in our board class. This is going to be where we store the state of the game and handle user input until there's a winner. In here, we're going to store some instance variables by accessing self. We're going to need a board array. This is going to be a 2D array with rows and columns for every slot that the user can drop a piece into. To do this, we use a for loop for every single slot here. And then when we have a row, we need to loop that many times to create that many rows, not just one. Just like that. Perfect. And then in this board class, we also need to keep track of the turns that have been played, as well as the last move inputted. Starts off as an invalid move because we haven't played anything yet. Just like that. Now, we need a reusable function to display the board to the terminal as the game goes on. We're going to call that print board, and we're going to pass in self. First, we're going to number the columns. Start off by printing a new line here, and then loop through every column. Now, we need to display what number this column is. We're going to use an F string here and pass in the value of this column. And we're going to plus 1 because we don't want it to start at 0, we want it to start counting at 1, right? Since we are continuing to loop through each number, we don't want a new line yet until the end of our loop. Now that we have the columns numbered, we actually need to print the slots for the game board. To do this, we're going to use 2 for loops, one nested inside the other. First, we iterate over the rows, and inside of that, we loop through the columns again. And up here, we did this separate just to keep the code a little cleaner, so you know which loop is doing what. Now, at the beginning of every slot, we're going to print this bar without a new line. And then for each slot, we're going to access the self.board variable using another F string. We're going to index into the row and then into the column. Just like that. Add another bar to separate the slot and get rid of the new line at the end. For at the end of every column, we also want to print a new line to separate it. Now, after the whole board has been printed, I'm just going to print a line break to separate everything in the console. using another F string, I'm going to use this handy Python trick where I can print 30 dashes all next to each other without having to type them out, just like that. So here's our print board function all complete. Now, to use this, we're actually going to need to create an instance of the board. So here we're going to write a play function, and we're going to assign an instance of the board to the variable game. And we can use this to call our print board function that was created inside of our class. Perfect. Now when we run this file, play is never called, so nothing will display. We actually need to set up our game loop. So here we use this little Python trick that will execute our play function when the file is run. Just like that. Save our file, open up the terminal. Right, Python 3, main.py, and there you have it. We have displayed our board here for the user to see. Now, let's go back in our code and fix the spacing. When we number the columns here, we're going to use one space before and after the parentheses. Now let's run our file again, and just like that. Now the user can see which slot is which number and the state of the game. Great. So now we have a play function that can handle the state of our game and display it. But how do we get the user to input their move and play the game? First, we're going to go here into our board class and write another function called which turn, which will access self. We use an array here of players, which could either be X or O. Now, based on the number of turns that have been played, which can be either odd or even, it's going to return X or O, just like that. Now we go back to our play function. We don't want to play the game with one turn. We want to play it over and over and over until there's a winner. So we're going to use a game loop. We set game over to false, and while not game over, continue playing, just like that. Now at the start of each turn, we access our game instance and display the board. Now, we need to actually ask the user for some input. So to start off, it's going to be an invalid move. We're going to create another loop to test the move every time the user asks to drop a piece in a given slot. Every time we're testing this, we need to ask for another input. And with an F string, we're going to ask the user for a column, just like this. So X's turn or O's turn, please pick a column 1 through 7, or 8 in our case, just like that. Perfect. So what happens if the user inputs a letter? That's not a column because they're numbered. Well, we're going to use a try block, and it's going to attempt to place a piece in the board based on the user's chosen move. It's not always going to be valid. So if it returns false, valid move is going to be set to false. If valid move is false, this whole loop is going to start over again, and we're going to ask the user to input something again. And it will ask the user, the same player, to execute their turn. Not a new one each time. The same one until a valid move has been inputted. Now here, we're going to create a new method in a moment based on the user's move. And we're going to subtract 1 so it's index format. Instead of 1 through 7, it's 0 through 6, just like that. Now, if the user types in a letter, we're going to get an error. To handle this, we're going to use the except block. Python's going to recognize that something went wrong, and we're going to tell the user, hey, you need to put in a valid move. Great. Now we need to write the turn function in our board class. Def turn is going to access self and also be passed in a column. This is going to test searching from the bottom up where the user is dropping their piece. Now we're going to loop through this column, starting at the bottom, working our way up until we find an open slot or we find no slots. We want to start at the bottom, go until the first row, 0, and subtract 1 every loop. Well, let's test this row within the column to see if it's blank. If it is, set this column and place the letter here. Execute this turn. Also, save our last move to this spot and increment the turns that have been played. Finally, we return true to indicate this was a valid move. If we search the whole column and we don't find anything, we run a return false to indicate that this column is full. Perfect. Now let's run our program here. So here we see our board displayed. I can pick columns 1 through 7. X's turn, pick a column 1 through 7. Let's place it in 3. Perfect. Drops it right there. It displays the board and it loops the game over with our game loop. Now it's O's turn. Pick another column, 5. Pick another column, pick another column. See, now I typed in 34 and it raised an error because there is no column for 34. Now what if I type in 8? That's not a column either. If I type in 1, that's a valid column and it inputs my move. Perfect. Next, we're going to write another function in our board class called inbounds. This is going to test if a row column coordinate is within our 2D array that we set. We're going to pass in self, pass in a row, and a column to check. Now, let's see if this is a valid move. If r is greater than or equal to 0, and r is less than the number of rows in total, and c, the column, is greater or equal to 0, and c is less than the number of columns set. This will return a Boolean, true or false, if this coordinate is inbounds. So where are we going to use this function? Well, we're testing all of these moves, and we can fill up the board as much as we want to. But the program doesn't know if there's a winner yet. In our game loop, if there was a valid move, it will be played. Now that that move has been played, there might be a winner. So let's check the game board. we're going to update the game over variable with a Boolean returned from check winner. This is going to be a new method we write in our board class. This is going to return true or false if there is a winner. If it's false, if there's no winner, game over will be equal to false. If game over is false, we're going to continue playing with our game loop. Just like that. So perfect. Now in our board class here, we're going to start our check winner function. In our check winner function, let's start off by tracking the last row with our last move instance variable and the last column, last move the second index, just like that. Now, when the player inputs their move, the last move that was played could be a winning move. It could make a connect 4. So we need to check all the spots surrounding that to see if they made a connection. Only the last move. And then to figure out which player that was, we're going to keep track of the last letter based on that last move. So by accessing the board, by indexing into last row and last column, we will get X or O. Now when the user drops their piece into a spot, they can make a connection diagonally, horizontally, or vertically. We need to test all of these directions in our 2D board array to see if there are 4 matching pieces, matching only, and no blank spaces either. So to test, we need to test every single possible direction. So we're going to indicate this with a little array, RC, which is the direction with row and column, and we're going to save the matching letter count in this direction. How many letters did we find that matched? And then we're going to also set a locked Boolean. Now you'll understand what this is in a moment. Let me just type this out for you. So all of the possible directions is going to be a long array here. In here, we start off with our first direction. So it's going to be the last row, last column, -1. So 1 row above. This is the direction. We're going up columns, column -1, column -1. We have found no matching letters, so we set that to 0, and then we set the locked bool to true, because we want to keep checking this direction. It's not done yet. Let's copy and paste this. Now, checking downwards. Checking left, checking right. Now we check diagonally. So now we have all 8 directions that could be possible connect 4 winner moves. Just like that. So we need to go 4 spaces out in all those directions, testing our board array. Now since it's connect 4, it could be matching up to 4 times 4 pieces out. For A in range 4. And now for every direction, we're going to test 4 times. So let's iterate through this directions array for D in directions. And then we're going to save the current row in current column that we're checking. From our starting point, which was the last move from the user, we're going to shift our position based on the direction. So it will be the last row shifted by our direction row and column amount. And then A plus 1, which is how many pieces searching outwards we're going. Are we right next to the last move, or are we 4 pieces away from the last move? We also need to save the column that we're checking. 0, 1. Oh, and then this row is 0. This column is going to be 1 times A plus 1. How far out are we? Now we save the row and column that we're going to be checking for this direction, this search. If D index 2 is still true, we're going to continue searching this way. If D2 and this position is still in bounds, RC, using the function we wrote for our board class, and self.board index R, index C, based on this spot, is a matching letter. If all of that is true, we're going to increment the letter count for this direction, right? So D index 1 plus equals 1. If this hits 4, that means it's connect 4. There's 4 pieces in a row that we're all matching without any breaks. If none of these are true, if it's not matching, if we're not getting a connect 4, we're going to stop searching. We're going to stop searching. We're going to stop searching in this direction. We're going to lock this direction. Don't check it anymore. Just like that. So now that we've actually counted all of the letters in all the directions, we're going to verify whether or not it was a valid winning move. So since you can have a diagonal winning move, it could be 4 pieces up and over, 4 pieces down and over, either way. So we kind of need to stretch across it and add up the aggregate matching letters. So we're going to use this fancy range here, where we're going to skip every other direction because they're connected. Now you'll see what I mean in a moment. So we're going to start at 0, end before 7, but count up 2 every loop. If directions index I, index 1. So if the letter count here, directions index 1 is the letter count, plus directions index I plus 1. So the corresponding direction, that could add up to 4. If it is greater than 3, if there are 4 in a row, we're going to print the board and announce the winner of the game, because there are 4 pieces here. Perfect. I'm just going to return the last letter, return true, because a letter is truthy. We're just going to return the last letter. Now, if we go through this whole loop and there are no winners, we're going to return false, because there is not a winner. Perfect. Now let's display this. Clear the console. Now let's run our program, and we have an error. So let's go back to our check winner function right here, and seems like our error is an extra parenthesis here. We'll remove that, open the terminal back up, and run our program. So X's turn. Let's drop it in column 1. Okay. Okay, another error. Okay, so we have another error here. We need to go back in our check winner function down to our for loop, and I forgot to index into the letter count of this direction. Open up our terminal and run our game. X, drop it in column 1. 0, 2, 1. So now if I drop it into column 1, it should display X is the winner. So what happened? We dropped our X piece into slot 1. It went into slot 1 and it checked all the way down, counting how many matching letters there were, and there are 4 matching X's, which resulted in a win. Now, what happens if the board fills up and there's no winner? This is our last thing to handle, where we go back into our play function, and then in our game loop, if there wasn't a winner, nobody won yet, but it could still be a tie. So we're going to check our game board. Now, we're going to use a quick loop with the any method that Python gives us, and we're going to check the game board for blank spaces. If there are no blank spaces, if the game is completely full, the game is a draw. And we don't want to prompt the user for more turns because the board is already full. And that's all. There you have it. Now we handled the game, the input moves, the game winner, and a tie. And that's our Python Connect 4. And that's it. Connect 4 in the command line using Python. If you want to see the code, check out the GitHub repo. Link is in the description. Follow me on Twitter for updates about code and tech. Subscribe for more videos like this. Stay tuned. Have a good day, y'all.